Hey everybody, welcome back. Another session brought to you for Math 335. Last time we went over systems of equations. And so we're looking at 9.1 and 9.5, a review of it. And why review the two-dimensional ones when we can do the 3D matrices? We had one, let's see, I think I got one example where we had a 3D one, and then we had an example where it showed up in real life. Let's take a look at doing some more. It's time to get set. Let's go crazy. Let's not go crazy. That's crazy. This problem here's got a 4x4. That's just batshit crazy. Let's do something like this. Plus 3z equals -2. That should be plus a 3z. That looks like minus 13z. Let's see, -12x minus 2y plus 3z equals -2. Yeah, 8x plus 5y minus 2z equals -6. 4x minus 3y plus 3z equals 10. We have some options. We can pick a letter to get rid of first. Now, Z might look like the easiest one to go with. Z looks the easiest. And it would be the easiest, but let's think endgame. When I get down to a 2x2 matrix, if I get rid of Z's, I'm going to be stuck with big coefficients. So I'll be stuck with big coefficients. If I get rid of y, oh my gosh, they have nothing in common, so I'm going to have to do a lot of work. Y looks like a terrible option. So y is a shit choice because there's nothing in common between the coefficients. X has something in common with all of them. And if we get rid of x, we'll be stuck with y and z, which has smaller coefficients. Smaller coefficients later. I think that's a good idea. I think that's something we should take a look at doing. So why don't we look at getting rid of x? Let me label these. Call them A, B, and C. And let me wait a few minutes as we have our sole student that likes to come to class is here. Let's give her a moment to write the question down. So if I want to get rid of x, the first choice I see that looks fairly obvious, it looks like using A with the other two is a good choice. Because 4, if I multiply 4 by 2, I get 8. If I multiply 4 by 3, I get -12. So maybe we should look at doing combinations of those. So why don't we do We can start off with any choice we want. Maybe let's start off with 3A plus C. If I do 3A, that'll give me 12x. So I'm just going to rewrite the equations as it, well, I'm going to write the 3A. And then I got minus 9y and plus 3z equals 30. And so that when I add those two, the x's go away and I get negative 11y plus 6z equals 28. Let's make sure I did that right. 3 times that is 12x, 3 times that is negative 9y, 3 times that is 3z, 3 times that is 30. If I add those two, I get 28. If I add those two, I get 6z, and I get negative 11y, and the x's cancel. Okay, that's excellent. That's what I want. The other idea is we could do B and A, and I'm going to need double A, and I'm going to need one of them negative. So maybe I'll do B minus 2A. So let me put a little box around this one that I'm going to use later on. And we'll call that D. So what's B minus 2A look like? B is 8x plus 5y minus 2z equals negative 6. Negative 2a is negative 8x, positive 6y, negative 2z, negative 20. And I add these up. And my x's go away and I get 11y minus 4z equals negative 26. Now, before I go any further, I want to just double check everything. I copied B down correctly. That looks good. Negative 2 times that is negative 8x, positive 6y, negative 2z, and negative 20. My multiplication is good. 5 and 6 is 11, negative 2 and negative 2 is negative 4, negative 6, negative 20 is negative 26. That's looking like a good equation as well. Sometimes it helps to just double check it again while you're doing it. Takes longer to do, but you're really saving yourself time in the long run. So now it looks like this looks pretty straightforward. I can just add D and E together, right? Let me rewrite D. So that's D. So we're going to do D plus E. And my y's go away right out the gate. That's pretty nice. That's beautiful. I got 2z equals negative 54. And so I divide by 2 and I get z equals negative 27. Not a great number, but I can work with it. Now that I have that, I want to plug it back into D or E. E has a smaller coefficient on Z. I'm going to go with that one. So I'm going to plug this into E. And if I do, I get 11y minus 4 times negative 27 equals negative 26. So that's 11y plus 108.
I have a question.
Yeah.
Isn't D, or is this E? Isn't it a negative 11y plus 6z equals positive 28?
You're right. That makes this a lot better. Good catch. Excellent catch. We were going to find out later on that we were wrong and have to go back and figure out where it is. But that makes this easy. Because now 2z equals 2 and z equals 1. And that makes that pretty easy. That's a 1. So I've got 11y, good catch. Add 4 over, I got 11y equals -22. And so I get y equals -2. Right now, we're looking at -2 and a 1 there. We just need our x component. Equals 1, y equals -2. And we'll go back to one of the original equations. It looks like A is the easiest equation to plug stuff into. I got 4x, oops, I wrote z, minus 3 times -2. Plus z is +1 equals 10. So I get 4x plus 6 plus 1 equals 10. That's 7. If I subtract 7 from both sides. Am I doing this? Really? There's a fraction in it? That's funny. -3 times -2 is 6 plus 1 is 7. Subtract 7. There is a fraction in this problem. And we conveniently did it right at the end. Oh my, we got lucky on that one. Something's wrong. No, that's right. Let's check it in B. If I plug it in there, I get 6 minus 10 is -4, minus 2 is -6. Excellent. If I plug it in here, I get -12 times that is -9. -9 plus 4 is -5. Plus 3 is -2. It works. So if we had solved for z first, we probably would have ended up getting x, either x or y first. But if we'd gotten x first, we would have been using 3/4 the whole way. So we got lucky. You guys want to go crazy? You guys want to like pick it up a notch? Like make it really hard here? And if it's really hard here, it's going to be really easy later on. Like nothing could be possibly be harder than this. Let's do it. (2x plus y minus z plus w). What? 4. Oh, that's a shitstorm right there. Sure that I'm picking the right ones. 2y, 1, -1, 1, -4, 1, 2, 2, -3, and 6. Then I've got 3x minus y minus z plus 2w equals 0. And I got 2x plus 3y plus z plus 4w equals -5. Four by 4, boom. It's the same process. We got to eliminate one letter at a time. Right now, I'll give you a chance to look at it and formulate an idea. Tell me which letter looks like the most easiest to get rid of for you guys. how to do some shit like this as an extra credit problem. Do a 4x4 matrix. This sounds like a great extra credit problem for the final. Well, let's look through the coefficients and look to see which one. At this point, with so many letters, I just want to get rid of the ones that's the easiest right now. I don't want to think about long term. Let's just go with the easiest. Which one has the smallest coefficients? Z. So let's kill off Z. Let me label these real quick. So it looks like if I add C and D together, this is going to be pretty easy. C plus D, we'll call this one E. Just add them up and Z goes away. 5x plus 2y plus 6w equals -5. Looks like adding together C plus A is pretty easy too. We'll call this new one F. C plus A is 2x plus 3x is 5x. Oh, this has got a bonus. Look at this. Wait, why am I doing C? D. That's a 4x now. Never mind. I need D plus A. I need the positive Z. 4x, and then I got a 4y. And then my z's go away, and I got a 5w. And I add -4, -5, I get -9. Is everyone okay with that without me having to rewrite out all the equations? Just adding them up as is. They're not next to each other, so you kind of gotta go patiently. 5, -9. All right, we need one more. We got to get rid of B. We got to narrow down B. So we're going to need to double up something. Let's do B and 2A. So I'll rewrite this right here. I'll rewrite B real quick. And then I'll do 2A. It's 4x, 2y, -2z, plus 2w equals -8. And I get 5x plus 4y minus w equals -2. And we'll call this one G. All right, so we got some options to get rid of. Next, we got to pick a letter. I don't like X because I got 5s and 4s, and that's not going to look good. And I don't like Y because I got 2, 4, and 5, so they don't have anything in common there either. So it looks like we're going to focus on eliminating W as a good choice here. So let's focus on eliminating W. If I do F plus 5G, I've got 4x plus 4y plus 5w. I'm rewriting F equals -9. And then I want 5 times G. 25x plus 25y minus 5w equals -10. And so I get 29x plus 29y equals -19. I'm going to call that H. All right, we did F and G, we now need to get rid of E. So maybe if I do. E minus or E plus. I need negative 6W here, so I need 6G. Now, let me rewrite these. And then 6 is 30x plus 30y minus 6W minus 12. I'm gonna call that J. This is crappy. This means we're gonna have fractions. No, we can do. We gotta pick one to get rid of. This, it might be easier. I hate doing this, but this is gonna end up with fractions no matter how we do it. So maybe if I divide by 29 here. I get x plus y equals negative 19 over 29. And I can subtract x over maybe. We've got to do a substitution. 35x plus 32 times negative x minus 19 over 29 equals negative 17. Okay, so this is going to give me negative 32x plus 35x is 3x. And I got minus 19 times 32 over 29. And then I've got negative 17 on the right. And it looks like I'm going to need a common denominator, so let's multiply that by 29 over 29. And I left my fucking phone in the car. And I found that out just now by checking my pockets, which is delightful. So let me get out a calculator on the computer here. So I got 19 times 32. So I got 3x minus 608 over 29. Let's do 17 times 29. Equals negative 493 over 29. And we're going to add the 608 to both sides, and we're going to get 3x equals 115 over 29. Is there any way, shape, or form that is evenly divisible by? No, there's no way. Divide by 29. Nope, that's still a decimal. All right, so I guess X just equals, well, we can do the 115. No, 115 isn't even divisible by 3. I do over 3 on both. This is 115 over 87. All right, so that's X. Let's figure out Y. Negative 115 over 87. Minus 19 over 29. And we need to multiply that by 3 over 3 to get the same 87. So clear. 3 times 19, I know this is 57. So 115 and 57. That's a negative. All right. So, now we got to go up to back up to one of the 3 first. I think doing G is the easiest because G's just got a straight W. Let's plug these into G. I got 5 times negative 172 over 87 plus 5 times negative 172. Wait, that was 115 right here. This was the negative 172. I'm going to real quick, I'm going to add 2, put the 2 over here and put the W over here. So plus 2 times 87% equals W. What? Okay. Let's see. 115. I'm going to do those together. 115 plus 172. And then times 5. This is 1435 over 87 negative plus 2 times that is 174 over 87 equals W. So which equals negative 1261 over 87. That's my W. We need to go all the way back up to the original equations. I need to pick one that makes this as easy as possible. I think maybe A is the easiest one. Maybe. Just because there's a lot of coefficients of 1. All the way up there on A. So we'll do A. We've got, I'm going to put the 1 over 87 out front. Because I'm tired of writing 1 over 87, or the 87 as a fraction. I can just add it later. I can do 2 times the top, 2 times 152x is 2 times 115. Plus, Oh shit, that's positive. I did a negative here. That's gonna change some shit. That's gonna change this side. Team 35 plus 174. 1609. Then I got plus y, which is negative 172. And then I've got plus w is the plus 1609. And then I got minus z equals -4. We'll probably have to do that as 87 over 87. So let's see, what does that all add up to? Plus 2 times 115. Make it clear. 2 times 115 equals. All right, 230 minus 172. 58 plus 1609. 1667. So I got 1667 over 87 minus z. I'm going to do plus, put the z over here and put the plus 4 times 87 over 87 on the left. Just to save some space real quick. This is 320 plus 28 is 348 over 87. And then if I add these together, 2015 over 87, which equals z. So, putting them in the same order they appeared, if I do x, y, z, w, (115 over 87), negative 172 over 87, 2015 over 87, and 1609 over 87. That didn't come through very clearly, but they're all boxed down here. That's a clusterfuck. That's kind of cool to do a 4x4 and then not even make it have good numbers. That's some cold shit. That was challenging, wasn't it? Got worse at the end. Dealing with the fractions at the end, I think, was even harder than trimming everything else down. This you can go through slowly at the beginning. Just figure out what you're going to get rid of and then focus on getting rid of it one letter at a time. It helps if you write down the letter, give it assigned letters, like something like that, so you can keep track of what you're doing. And then you go from there. I guess I could have called this one here K. And I didn't. All right, we'll let that soak in for a little bit. These don't take too long to do, so I'm not going to start another one. Let's see, what do I want to do with the next section? Partial fraction what? Decomposition. I think I should do one of those problems first, though, in this section. But I need to do it with the other students. Stop on recording here.